So today, in lesson 3, we are going to be talking about multiplying binomials. Multiplying binomials. Here, I'm actually going to move this up so I just have a little bit more space to work with. Multiplying binomials. How many terms are binomials? 2. So, when I take a look at every single problem that you will have in your homework today, each of them are going to look like this. Okay? X plus 3, so this kind of, we're going to model this, we're going to talk about it, and then we're just going to do the kind of learn a new acronym today. So, when we multiply and we see different terms, like we've got the x and the 3 and the x and the 6, if it was just a 3, like yesterday, or even earlier on in the school year, we would distribute, right? We would distribute the 3 to the x and to the 6. Likewise, yesterday, if I just had an x and the x plus 6, I would distribute the x to the x and the x to the 6. Now, let's kind of write this out as if we are distributing. Okay? So this expression is the same thing as, if we think about the distributive property, would be x times x plus 6 plus 3 times x plus 6. Okay? So we're taking the x and we're distributing it to the x plus 6. We're taking the 3 and we're distributing it to the x plus 6. Now, this is kind of what we saw in one of our examples yesterday. So if I'm now distributing, what's x times x? Not 2x. X to the what? Yes, x to the 2, x squared. Okay, this is what's really important. We are multiplying. Okay, x times x is x squared. Then it is x times 6. So it's 6x. The next one, if we do this one, 3 times x. And then 3 times 6 gives me 18. 3 times x, 3 times 6. Now, having to write this is cumbersome. It's kind of tedious. There is a shortcut. Okay? Now, I want us to take a look at this first expression here. To get the x squared, x, right here, how would you describe the position of the x's? Like when you look at the terms and you're trying to use words to describe what spot the x's are in, what word do you think you could use? What spot, if I just looked at that, what spot is that x in? No, like if you had to describe this position, how would you describe that compared to the 3? No, don't think about graphing. It is the first one. How about that x? It's also the first one. First. To get x squared, we multiplied the first spots. How could you describe the x and the 6? No, the x is the first. If x is the first, we can't use that word again. How would you describe the x and the 6? What kind of positions in our expression are the x and the 6? Opposite and let me suggest the outside. They're on the outside of the expression. Outside. They are the outside. How about the 3 and the x? Inside. How about the 3 and the 6? Now think about how the x's were the first. What about the 3 and the 6? Ooh, that would mess up. If we did second, that would mess up our acronym. How about last? 3 and 6. F-O-I-L. Foil. Foil. Inside. Foil. Foil is your new best friend. We will use foil. Got this. In lesson 3. In lesson 4. In lesson 6. Lesson 7. And lesson 8. This lesson is very important. I teach you how to foil. Then I will teach you how to unfoil. No, unfoil. It's called factoring. Un-U-N, unfoil. So there's like I undo the foiling. Read you. Yes. So foil, now, well, I guess it is kind of anti-foil because anti, get this, anti means replace. So like in the Bible, when you see the word Antichrist, the Antichrist is replacing Jesus as like the worldwide ruler. So it can also mean against. But yeah, anti can mean instead of. So this lesson, what we're going to be doing today, is going to be important for the rest of the chapter. Okay, so that's why we're spending both today and tomorrow working on it. Okay? Foiling is the same thing as distributing. It's just an easier way of remembering it. So, foil. First, outside, inside, last. So my answer is x squared plus 9x plus 18. Guess how many story problems we have today? 0. Is there a question? Dude. No, because you're just adding them. The only way exponents will change is if we are multiplying. Like x times x became x squared. Yep. So here is our example for today. Use FOIL to find each product. Okay. Use FOIL to find each product. Okay. So just like in this example, or this modeling this and explaining it, where there is just the x as our one variable, same thing in the example and in the homework. There's just going to be like one kind of variable. So here is the first one. Oh, I'm already thinking about foiling. I was about to spell it out. X plus 2 times x minus 6. X plus 2 times x minus 6. Here are a few things that are important to mention. Foiling works no matter what kind of expression there is. So the fact that there is adding and subtracting, foiling will work. Okay? So if we're using FOIL, the first terms, what is x times x? X squared. Oh, outside, what's x times negative 6? Negative 6x. Inside, what's 2 times x? 2x. And then last, what is 2 times negative 6? Negative 12. Then I simplify. Plus 2. Then we simplify. Can I combine the x squared with anything? How about the negative? Yeah, so negative 4x minus 12. All right, so I'm going to ask you a question. This is just extra because I want us to start thinking about some of these numbers. What two numbers multiply to negative 12 that add to negative 4? What two numbers multiply to negative 12 that add to negative 4? And not just 6. No. Negative 6. Negative 6 and 2. For ones like these, when we do these examples, I will be like asking you to be thinking about that, because that is going to be a very important part in lesson 6. Okay. Very important part. I want you to do this next one. X plus 11 times x minus 3. X plus 11 times x minus 3. Here are a few things that as I walk around, a few things worth pointing out. These problems, no fractions. They'll only be ever integers. It depends on if the number itself is negative or positive. Yep. So if you're doing a positive number, that's negative number. Okay. Stella, what is the first term? What is the first term? X squared, good. Jocelyn's in the restroom. Cade, what's the product of the outside terms? Negative 3x, good. Jocelyn, what is the inside? 11x. And then Jake, what's the last? Yes, good. So we FOIL, then we simplify. Lincoln, what is our answer? What are our only like terms in this expression? Yep. So what's negative 3x plus 11x? It's negative 3x plus 11. 8. So what's our final answer going to be? Our final answer. It's not just the middle part. What's everything? Yeah. Well, if the only things that we're combining, if the only thing that we're combining is negative 3x plus 11x, what's the rest of it? If it's x squared, then there's too much whispering going on for me to hear. What's the next term? 8 what? I'm waiting. You don't know it yet. I'm still going to wait. What's negative 3x plus 11x? Go ahead, Judah. What's the answer?
It's going to be x squared plus 8 minus 83.
8 what? Yeah, there's still an x there.
All of them in there.
All right, let's do another one. All right, here's the next one. 2x minus 3 times 3x plus 1. So we FOIL, even when it looks like this. What is it when we multiply the first terms? Plus 2x. Since it's just 2x times 1. Jay Sean, what is the inside terms? Yep, so it's negative 3 times 3. Yep, negative 9x. And then how about the last term? Negative 3. Good. Negative 3 times 1. So what kind of was my final final answer going to be?
6x squared, and then 7x.
Good. Well, this simplify. Okay. Your homework is 1 through 6, 12 through 19. Page 483. 1 through 6, 12 through 19, page 483. Because I want you to get the most of this homework done before tomorrow, you can take the next 10 minutes to work on your own. So, alrighty.